So this experiment is about safety and also about lab familiarization. So for this experiment, we are going to measure voltage. We're going to go over how to measure current, and also we're going to construct a circuit, and we want to measure resistance as well. So as you can see, the circuit that we're working with, we have one power supply, which we'll be getting from the microcontroller. We also have an LED, which we'll be using as a light source. And also we have a resistor, which is going to be limiting the current. So this resistance is going to determine the current that is flowing in the circuit. And we have a voltmeter that we're going to use to measure the voltage across the LED. So before we begin, we need to measure the power coming from the Arduino. So we have two wires connected to, one is connected to the 5 volts of the Arduino, the other one is connected to ground. And I'm going to turn the meter to the measure voltage, and I'm going to measure the voltage coming from the Arduino. We're going to take 3 measurements, okay? And these measurements are going to be written in this table right here, okay? So the first measurement is 5.05. So I put it right there, 5.05. And of course, this unit tells me it's in volts. Okay, so I can disconnect it and connect it again and take another measurement. 5.06. 5.06. Okay, let's do it one more time. Okay, 5.05. 5.05. And we're told to take an average of this. Now, average is the sum over the number. So average is the sum over the number. In other words, 5.05 plus 5.05 plus 5.06 divided by 3. And that average gives us 5.05. So we'll just use 5.05 for the average. Okay, now we're told to, so this is the supply voltage. As you can see, the light is on. So we have voltage coming out here. Then we are told to measure the voltage across the LED. So to do this, we need to construct the circuit. And this is the circuit that we have here in the lab. Okay, it's the same circuit as this one. And if you want a pictorial, we have a pictorial diagram here showing the connections from the Arduino. So this 5 volts from the Arduino, the positive from the Arduino, the 5 volts goes to the longer lead of the LED. As you can see, the LED has 2 pins. One is longer than the other. The longest one is the positive one. So let me put this in here. So the longest pin goes to the LED. Now the LED then is connected to the resistor. So let me go ahead and set this up right here. So the positive goes to this pin, and this other pin should be connected to the resistor. And the way that I do this, I put it in the same row as the resistor where it is connected, so that we can have the connection. So the positive goes to this pin of the LED, which is the longer pin, which is the positive terminal here. So here you can see that clearly this is positive and this is negative. So from the power supply, again, this is positive from the power supply. This goes to the positive pin of the LED, and the negative pin goes to the resistor. So this one is positive here, and this one is negative. So it's connected to the resistor. And then the other leg of the resistor, the other lead of the resistor is connected to ground. And to do this, we could take this ground here from the power supply and connect it there. Voila, you see that our light comes on because current is flowing. So we know that we have connected our circuit properly. So the reason why we said we need to use the longer lead of the LED, because if we put the LED the opposite way, if we flip it and we put it back, it will not work. Alright, it will not conduct electricity, it only works in one direction as a one-way valve. So now we know we connected it properly. So the question asked on the table, or the step in the lab said that we should measure the voltage across the LED, and we should take 3 measurements of this. So let's go ahead and take these measurements. So the first one says 1.7, 1.735, 1.735, volts. All right, let's take another one. So to take another one, I disconnect it, I reconnect it. 1.735. That's cool. 1 point. It's good. 735. Again, take another one. So disconnect it, and I'm going to reconnect it. 1.734. 1.734. Okay, and our average will be 1.735. If I calculate the average, it will be 1.735 volts. Alright, then it says measure the voltage across the resistor. So now we're going to measure the voltage across the resistor. So this voltage is 3.296. 3.296. Okay, let's take it again. So I disconnect one leg and I reconnect it to get the second measurement. 3.274. 3.2. 3.266. Okay, I was at 6.4. 6.4. Okay, I'll take one more measurement. 3.25. Okay, 3.26. 3.266. So the average will be 3.266 plus 3.264 plus 3.296 divided by 3 will give us 3.275. 3.275. Okay, then we are told what is the current flowing in the circuit. Now we need to configure the meter now to measure current. And the way we do that is, if you look according to our diagram here, we need to interrupt the circuit and make the current flow through the ammeter. Also, we need to change the configuration of this. So let's start first. Let's disconnect the power here. First thing we need to do is let's put a meter to measure current. So we're going to put it on 400 milliamps because we expect a small current. And then we need to move this red lead from the volt ohm port to the milliamp port because we are measuring current. So this one is on milliamps, and we need to also move this one to be on milliamps as well. Then we see that the ammeter has to be a part of the circuit. In other words, the current is flowing here, it's flowing, and it has to pass through the ammeter, and it has to come back out. So in other words, the ammeter becomes almost like a jumper in the circuit. So this circuit is already flowing. In other words, you need to interrupt the circuit and make this one a part of it. And so the way we do that, let's do it on this end here. Oh, they did it on. So in the circuit, the ammeter is right after the battery, so we can do it this way as well. So the 5 volts from the battery now should go to the positive probe of the ammeter, and the negative probe of the ammeter, the current will be coming out, right? Because remember we said current is the amount of charge that flows in the circuit in 1 second. So this ammeter is measuring how much charge is flowing in the circuit. So the current has to flow through it. So then the output will be on this LED right here. Okay? The output will be right here. Okay? And in case this meter is broken, I have a second one for backup. So let's try the second one. TV magic. So now we can see the amount of current that is flowing. So the current that is flowing is 6.86 milliamps. So we go ahead and measure that and write that down. So again, we see we change to milliamps here. We change the port of the red lead to the milliamp port, and we also interrupted the circuit to make the current come from 5 volts and flow through the meter, come out from the meter, and then go to the LED. So we have 6.87 milliamps. Okay, let's take another measurement. So to do that, we'll just disconnect it and reconnect it. So we have 6.86 milliamps. Okay, and let's do it one more time. Alright, 6.86 milliamps. So our average, we can use 6.86. Then we need to measure the resistance of the resistor. Very easy to do. So to do this, let's disconnect the circuit. We don't need any power, so we'll disconnect the power. And we need to reconfigure the meter. We need to put it back to measure resistance. So the symbol for resistance is the ohm. So we need to turn the meter to the ohm symbol. Then we also need to replace the lead. We're going to put it back where it says V and ohm. So essentially it says it can measure voltage and also resistance. Now we simply measure the resistance of the meter. Put the probes across the meter. No power required to measure resistance. And we'll see what the resistance is. So here we have 0.467K. And our K is 1000, so that means that it's 460 ohms. So I'll write that down, 460 ohms. Okay, let's do it again. So I disconnect it and I reconnect it. Okay, it's 460 ohms. And let's do it one more time. Okay, it's still 460. So that would be our average as well. Alright, and we are practically done. We have one more step, and that step is now to just do some calculations with the data that we have obtained. Alright, so it says here, what is V? Of course we knew V is voltage. So it says V over I. So it wants us to divide the average voltage here by the average current. So that would be 5.05 volts divided by the current. Average current is 6.86 milliamps. Now keep in mind that 6.86 milliamps is the same. So 6.86 milliamps is the same as 0.00686 amperes. Alright, so we need to have milliamps here so that when we calculate it, we'll get the correct answer. So our answer, 5.05 divided by 0.00686 gives us 7. Seven, 3, 6.15. Okay, we don't have any units for the output as yet. Now for V over R, let's do V over R. V will still be 5.05. 5.05 divided by R. And R there is 460. So we have 460 okay, and that will give us 5.05. That will give us 10.97 milli. So basically it's 0.0197. And lastly, we have R times I. And the R we're going to use is 460. So this will be 460 times total average current, which would be 6.68 milliamps. 6.68 milliamps. Okay, so that would be 460 times 0.00686. Okay, 668 or 686? Okay, it should be 686. Which gives us 3.1556. Okay. And we have come to the end. Thank you so much.